Historians of science have long agreed that the discovery of oxygen marked the birth of the modern science of chemistry. But they're still debating who discovered it. Joseph Priestley was the first to publish his discovery of the remarkable gas he called dephlogisticated air. Antoine Lavoisier gave the gas its modern name and was the first to understand its true significance.
But it's more complicated than just Priestley and Lavoisier, because there was a German-born scientist who was working in Sweden who appears to be actually the first person to isolate oxygen.
This third man in the oxygen story was an apothecary named Carl Wilhelm Scheele, who would go on to have a hand in the discovery of 5 elements.
Scheele was a very good chemist. In fact, Lavoisier had sent him one of his books as a compliment for some good chemistry that Scheele had done.
The story of these 3 men is a tangled tale that pivots on the events of one fateful week in October 1774. By this time, Lavoisier, one of France's brightest young chemists, had made a critical discovery: that when a metal rusts, it increases in weight by absorbing something from the air, just the opposite of what chemistry's reigning theory held. He also found that when he burned elements like sulfur, they too gained weight, apparently by absorbing the same gas.
I felt I must secure my right to this important discovery. So I deposited a note with le secrétaire de l'Académie to remain sealed until I was ready to make my experiments public.
But over the next 2 years, Lavoisier searched in vain for the identity of this mystery gas. Meanwhile, across the English Channel, Britain's leading expert on gases, Joseph Priestley, was experimenting with a curious substance called the red calx of mercury, which could be turned into liquid mercury simply by heating it.
That reddish substance in turn decomposes, giving back mercury, but also a gas.
Priestley collects this air because he likes to test these gases and to see what properties they have.
Priestley expected it to be carbon dioxide, or what was then called fixed air. If so, it would put the candle out.
But what he found about this air was it had quite extraordinary properties.
What astounded me was that the candle burned in this air with remarkable vigor. The flame was bigger and brighter than in ordinary air.
Something in this air seems almost better than normal air, which is very puzzling.
I was utterly at a loss. How could I explain this?
Eh bien, chers amis, buvons à la santé d'Archimède.
Dr. Priestley, have you been to the continent before?
No. This is my first time.
2 months later, on a visit to Paris, Priestley was invited to dine with the members of the French Royal Academy of Sciences, including Antoine Lavoisier.
J'ai récemment réalisé.
Priestley tells Lavoisier in his very broken French about his new discovery.
Les résultats. I told them that it produced a kind of air in which a candle burned much better than in common air. Mieux que dans l'air commun. At this, the entire company, including Monsieur and Madame Lavoisier, expressed great surprise. I'm sure they cannot have forgotten these events.
Lavoisier was smart enough to recognize that Priestley was onto something and take that piece of information and go back to his lab to figure out exactly what Priestley had discovered.
Could this be the gas he was looking for, the one involved in rusting and burning? Lavoisier hurried to the local apothecary to buy his own sample of mercury calx.
Within a week of the dinner with Priestley, Lavoisier got a letter from Scheele in Sweden. And in that letter, Scheele reports an experiment on making a new air.
What he calls in German Feuerluft, or fire air. It's in fact what Lavoisier will later call oxygen.
So here is Lavoisier in October 1774, and two people have told him how to make a new air, actually the new air that he needed to complete his theory. So what does he do with that? When he hears of Priestley's discovery, when he reads Scheele's letter, Lavoisier, realizing that this is essentially the key to the mystery, gets to work on it.
3.
Lavoisier repeated Priestley's experiments and then announced his findings with great fanfare at the Easter meeting of the Academy of Sciences.
I found, much to my surprise, that this air had none of the properties of fixed air. A candle burned in it with a dazzling splendor, and charcoal, instead of just smoldering, threw sparks in every direction.
Lavoisier essentially told the French Academy of the properties of this new gas that Priestley had already observed, using indeed the same word Priestley used. Surprise!
All this evidence convinced me that this air is more breathable, more combustible, and more pure than even the common